This training module will explain information needed for interpreting dependent water quality variables for use with the Stochastic Empirical Loading and Dilution Model SELDM. This is training module 7.02b. This presentation has 7 slides and will take about 5 minutes. This presentation was prepared by the U.S. Geological Survey in cooperation with the Federal Highway Administration. This module has 2 learning objectives. We will learn to describe the method for generating data with a dependent water quality relation and describe the advantages of a dependent water quality relation. A dependent water quality relation is a regression equation with random variation around the line. SELDM generates a random value for one water quality constituent, xi, applies the regression equation to get the average value of the dependent variable, y, and then adds a random term to get a random value for the dependent variable, yi. To simulate water quality, the regression equation should be developed with the logarithms of concentrations. The residuals will be normally distributed in log space, and the relation will not produce negative concentrations. This graph shows the number of samples by constituent in the highway runoff database. We can use dependent quality relations to predict one variable with little data from another which may have much more data. For example, the USGS and other researchers have indicated that total suspended solids method is fundamentally unreliable measure of sediment in runoff and receiving waters. These studies indicate that suspended sediment concentration is much more robust. We can use total suspended sediment concentrations, which have the most values in the highway runoff database, to model suspended sediment concentrations, which have fewer samples and sampling sites. Furthermore, this method allows us to produce regulatory total suspended solids concentrations from the highway and BMP and lets us model more realistic sediment concentrations in the upstream and downstream flows. This graph shows the dependent relation between total suspended solids, TSS, and suspended sediment concentration, SSC. SSC is on the vertical axis and TSS is on the horizontal axis. The white line is the one-to-one line, the yellow circles are the data. We can see that most of the SSC values fall above the one-to-one line. This is because TSS does not capture the sand size fraction in stormwater. The yellow line is the log-log regression between TSS and SSC. Using the logarithms of data linearizes the relation, normalizes the random variation, and prevents generation of negative concentrations. We can use this relation to model SSC by using TSS. To do this, we may model TSS as a random variable, use the regression line to estimate an average SSC for each TSS value, and then use random scatter around the line to generate an individual SSC value for that TSS value. The gray circles on the graph are the stochastic population of SSC values generated as a dependent variable by using a stochastic population of TSS values. Also, we can use dependent water quality relations to use something that is easy and inexpensive to measure to predict the hard or expensive constituents. In this example, a dependent relationship has been developed to estimate suspended sediment concentration from turbidity measurements at the U.S. Geological Survey stream gauge on the Little Arkansas River near Sedgwick, Kansas. The dark blue circles are the data points, and the yellow line is a regression relation that was developed with the logarithms of data. Using the logarithms of data linearizes the relation, normalizes the random variation, and prevents generation of negative concentrations. The light blue data points are values that were flagged as having problems. These data are not used to estimate the line or the random variation. Flow-weighted event mean concentrations for turbidity can be calculated from real-time data. SELDM can model turbidity from the event mean concentration statistics calculated by using the real-time data and can model SSC by using the relation with random variation. In this module, we learn that a dependent water quality relation is a regression equation with random variation around the line. We can use dependent relations to predict one variable from another to fill gaps in the dataset. We can use dependent relations to use something that is easy and inexpensive to measure to predict hard or expensive constituents.